Welcome to the lecture on Introduction to Preheat and Postweld Heat Treatment. So, we have talked about the heat treatment processes, and there we came across different type of heat treatments which are given. We talked with reference to the material, that is steel, but then that can be for any material. And then we also had the idea that how that heat treatment is able to change the properties, or with one specific objective, what kind of heat treatment has to be given. Now, when we talk about the welding process, now in that case what we see that you have the formation of the heat affected zone, and certainly this zone width or the extent to which the heat affected zones are formed. So, that is an area of concern. So, many a times for for getting the optimum properties of the welded joint, we do certain measures. That measures may be the necessity many a times for the successful welding operation, and many a times some of the processes are done some either preheating or the post weld heat treatment processes are employed to so that you are ensuring a better property in the welded joint. So, in that direction there are two things which we must know. One is the preheating of the specimen which is to be welded or joined, and another is the post weld heat treatment, because after welding also, as we have seen there are likelihood of the development of stresses and all that. So, normally we will have to understand what is the why there is need of preheating, what is preheating and what are the preheating methods. Similarly, why post weld heat treatment is required, what are the advantages associated with that, how that is applied to different materials. So, coming to the preheating, if you talk about the we have talked about the HAZ, and as we have seen that the embrittlement in the HAZ, they may be avoided using the preheating and post weld heat treatment methods. So, as we can recall that if we talk about our discussions regarding the HAZ, so in that embrittlement is a serious issue, and embrittlement is formed because of many reasons, and for that that may be avoided in the heat affected zone using the preheating and the post weld heat treatment methods. So, using preheating, the total temperature drop is reduced, while post weld heat treatment is primarily aimed for the stress relieving treatment. So, normally what happens that when you are not doing the preheating, so actually the actual temperature drop, you have the temperature which is attained to a very high level, and if you see the specimen temperature where the heat is flowing, so they are at the room temperature. So, basically in normal case the temperature drop is quite high. So, that gives a very large cooling rate. So, and that too because the welded weld metal zone which is surrounded by this metal which is having very high thermal conductivity, and then if the temperature is so high, so in that case the cooling rate becomes very high. So, what happens that when we do the preheating, in that case the difference between the weld metal zone temperature and the parent metal temperature, I mean through which the heat has to be pass or heat has to flow, and that will set up the temperature gradient which has certain value at any moment. So, basically that temperature gradient will be less if you are heating the specimen to a certain temperature. So, that is how this preheating concept is coming into picture, because that very high cooling rate that leads to many a times the unfavorable type of microstructure. So, what happens that if you talk about normal case of iron. So, suppose if we take the steel case. So, in normal case you have if you do the without preheat. So, what we do, we have the we are decreasing the temperature from 1540 degree centigrade to about 30 degree centigrade. That is, if you take the 30 degree centigrade as the room temperature. So, in normal case we are taking this specimen to this temperature. So, your temperature drop is about 1500 degree centigrade. But if you preheat, so if you if preheated to about 300 degree centigrade. So, in that case your temperature drop will be maybe about 1200 degree centigrade. So, here temperature drop is temperature drop is about 1500 degree centigrade, and here the temperature drop will be close to 1200 degree centigrade. So, that will lead to the reduced cooling rate and that gives the different properties different cooling rate will be giving you that there are other associated results also because of that. And also you will have the once you do the preheating. So, in those cases the properties of the material also is likely to be changed basically. So, more rapidly these and when we talk about the multi-pass welds. So, in that what happens that the bead which is deposited, basically you have the earlier bead which is being laid over, that is it seems like it is the preheated kind of preheated condition is there. So, you have the interpass temperature, that is that you can say that it will be the preheat or the interpass temperature. Now, normally when we talk about the post weld heat treatment. So, the post weld heat treatment is it's basically if you talk about. So, they are normally intended for the primarily for the stress relief treatment. So, what happens that when there is a large cooling rate. So, many a times when we are mostly doing the welding for the high carbon steel or high alloy steel, then the post heating is also important. If not preheating, the post heating becomes important. So, what happens that the preheating basically will be controlling the cooling rate that way. And but when we look at the post weld phenomena. So, basically there will be chances of the formation of residual stresses after while cooling. So, in those cases if the residual stresses levels are to a higher amount, in that case that may lead to the decreased service life of the component. So, that way the welded component may fail. So, post weld heat treatment is mostly for for the stress relief treatment. Now, if we talk about the aim of preheating. So, if we try to summarize these points which we discussed and try to look at other points also. So, apart from what we discussed, the aim of preheating may be because when we see that you have the well metal zone and also you have so you will be having heat losses from the weld area. So, so one of the purpose is to reduce the heat losses from weld area. So, that is one of the aim. Next will be to reduce the crack by preventing the formation of hard surfaces. So, to reduce crack formation by preventing formation of hard surfaces. Now, this is basically directly related to the formation of hard surface when we have the higher cooling rate. So, when you have the formation of hard surfaces, then the chances of the crack formation will be higher and these cracks basically, so that they will limit the properties, especially the ductility properties of the material. Now, also there will be another aspect, that is your expansion and contraction rates. So, because the temperature difference becomes smaller as you preheat the material. So, temperature difference becoming smaller, the contraction and the expansion will be different, because the coefficient of that value multiplied by the temperature difference. So, temperature difference if becomes less, then that order will also be less. So, you have reduction of expansion and contraction rates. So, once you have the reduction of expansion and contraction rates, so they will reduce the chances of distortion and residual stresses, basically the residual stress which is there inside the material. So, that leads to the distortion of the material. So, once you have the reduction of these values, so your chances of distortion and residual stresses are becoming less. Next, another important objective of preheating is that many a times you have the surfaces of during the welding in that zone, they may have moisture or they may have some grease or some kind of material which have moisture. And if you don't if you do the welding, so there are likelihood of having the entrapment of those grease or maybe moisture may be trapped into. So, that way you can reduce those chances if you preheat. So, if you are preheating, then they will be blown away, they will be they will be turning into vapors, and then you can get rid of those undesirable consequences. So, it is used to burn grease, oil and scale from joint area. So, that may also lead to the, so that will also necessitate or that will also result into faster welding, because many a times you have to remove them, you have to have the external means to remove these scales or maybe grease and oil by cleaning it. So, that will take an extra time. So, that will also help in reduction of the time, so that will increase the speed of the welding. So, then once you do the so it will also keep bead more fluid for more time. So, that will avoid the stress concentration, and the notch effects is also reduced. So, preheating it also brings that will be the weld bead to be in fluid state more. So, and with flat surfaces, and then that will avoid stress concentration due to notch effect. So, that is another reason which is preheating is given. And also when you have the fluid or liquid metal is there for longer time, then many a times you are giving more time for the gases which are dissolved into the weld pool. So, you are giving more time to let them come out. So, that is another advantage of the this preheating method. So, they will be coming out from the weld and HZ. So, they will be giving sufficient time for the hydrogen to come out. So, that will be helping to improve the microstructure, and the embrittlement which is there because of hydrogen. So, that also can be avoided. So, that is another advantage of the or the another aim of the preheating. Now, the preheating is normally done from 100 to 300 degree centigrade. So, that is normally the practice. However, we can go maybe at to higher temperature also, maybe up to 600 on degree C also the preheating has been reported. Now, the preheating has basically some effect also on the HZ formation. So, although preheating will be improving the quality of the weld, but then it it leads to bigger HZ, because you have up to more reason the effect of temperature can be seen. So, what happens that when you do it has been done for the steel. So, this was for 1040 steel, and when the fusion zone and HZ zone were measured, then it was seen that when you do without preheating, the zone was a little narrow, whereas when you did with preheating, that zone became more wide. So, basically you can understand by referring to some schematic figures, like your fusion zone earlier was this, and your heat affected zone suppose was it can be shown by this way. So, you have some temperature also in those zones. So, if suppose your heat affected zone is like this. Now, if you preheat, if you are preheating to maybe 250 degrees centigrade, so it was seen that this zone basically got widened. So, this fusion zone as it was earlier here, so fusion zone became somewhat wider. Similarly, the HZ zone also became somewhat wider. So, this way the HZ zone and the HZ zone was seen to be more wide when we did the preheating. Then this preheating what we do, they basically depend upon other factors also. They are the geometrical factors or technological factors are there. So, that also determines what should be the extent of preheating in those cases. Then once the more thing which we should know, that there are tests which tells to ensure that whether preheating is required or not. So, for that there is a test for that, and what we do in that. So, that test is normally known as the clip test. So, in that test normally what we do is we have a clip and or a lug. So, that it will be attached that will be welded. So, and then you try to hammer and you try to break it. So, depending upon type of breaking, the way it breaks, you can say that whether the preheating is required or not. So, normally what is done is, so you have basically this way you have a welding of a clip or lug is done. So, you have such a geometry. So, and then you have on this, what you do is you are attaching this. So, this is attached and so this will be attached to it, and now this is welded. So, so here it will be coming as the welded part. So, this will be your this is the weld bead which is welded here, and then it will be. So, what you do is in this case this is your clip, this clip is welded, clip or lug is there. So, this is now this in this dimension is taken about 13 mm, and this area is this area which is taken, this is about 52 or 75 mm square. So, that area is there, and that will be attached to a steel plate. So, this steel plate is there, and this is made of say low carbon steel, and this is the convex fillet weld. That is in that pattern you are welding this material. This material is made of alloy steel. So, this is a steel plate made of alloy steel, and on this you are welding this low carbon steel clip which is of that requisite dimension. Now, on this you will have you will be doing the welding to in normal conditions, and then you will be allowing this weld to cool at to room temperature, and then what you do, that you are trying to break it. So, you will be breaking by hammering. So, what you will do is, so suppose you have this specimen. Now, this is welded specimen which you have formed. So, now you will be breaking that with a hammer. So, that you will be breaking So, now and you have the welded this is your bead which is will be looking like. So, now if you, so what you do is you are going to break this so you are going to hammer with number of blows to cause the failure in that weld bead. Now, what happens that the failure may be in different way. So, now what we do is that there will not be much of the underbead cracking. So, the failure may be if you look at the failure modes. So, it may fail so that may go into this that way, and this so this may fail, or what it may do also in some case. Now, in some case that this will completely come out so this will be completely coming out, and this way your bead will completely come out from here, your material will be there. So, there may be two ways by which this what you will see that it will be failing. So, if you see that the failing is through the lug, then in that case there is no serious threat. So, but if it takes out some parent metal from here, so if there is if there is some parent metal coming out and there is depression caused here. So, in that case there is need of the preheating in those situations. So, that indicates this is the test which ascertains whether there is a preheating requirement or not. Now, coming to the post weld heat treatment. So, as we discussed that the post weld heat treatment is mainly the stress relief treatment. In that case we try to relieve the stresses which are generated during the cooling of the welded specimen while it gets cooled. So, the stresses which are there inside, these stresses need to be removed, and unless they are removed that may result into the formation of cracks. So for that these stress relieving treatments, that is done after welding. So, that is they are known as post weld heat treatment methods. So, in that what we see is you have the post weld stress relieving. So, we will talk about the residual stresses also, and what happens that after the welding is complete, then the residual stresses may be there inside the specimen to a very high level, and that may lead to the cracks in the material. So, what we do normally is that we to remove the residual stresses, the most simple operation is to anneal the specimen. So, many a times the most simple solution is to anneal the weldment, but then many a times it is not the practical solution because of the different shape of the fabricated component. Also, what happens that when you do the full annealing, in that case that may lead to the grain growth of the grain growth inside the material, and the grain growth basically will lead to the deterioration in the mechanical properties of the material. So, many a times we have alternative practices for the post weld stress relieving, and these are like you go for subcritical or low temperature annealing. And we also do the annealing locally. So, we can go for local low temperature stress relieving. Heat treatment in and around the weld. So, that is normally done using the portable hand torches. So, torches are used for doing these things, but they are normally cheaper and they are normally not very much reliable. So, you have otherwise other methods for doing that. So, you have automatic traversing torches, and you have special burners. So, with that we do. Another purpose of the post weld heat treatment is the stabilization of structure. So, what happens, as we know that during the welding process your the structure which is obtained is normally metastable because of very large cooling rate. So, and also it may change with time, it may there may be subject to aging or so. So, and then so normally we have to stabilize the process, so that so what we do is you homogenize the structure using the proper annealing operation or the normalizing operation. So, and then apart from that you also have the reformation of the structure. So, that is they are there is full solution treatment is given. So, this way the structure which basically are required to be modified many a times, because you have the metastable structure. So, you give those solutionizing treatment, or you give the proper heat treatment, so that the stable structure is formed. So, we will talk about the methods of the preheating and post weld heat treatment methods, and also applied to the different materials, how it is applied in our coming lectures. Thank you very much.